Hi, everybody. Okay, so this is going to be your little introduction to how we can represent structures on paper. So we learned from our lab that there are general structures of compounds. If you have a singular ionic compound, the lowest whole number ratio of that ionic compound, we call it a formula unit. And then if you have multiple of those formula units that build on top of each other, what you create is an ionic crystal. All of these little formula units just build on top of each other in this very rigid structure, and that structure is called a crystal lattice. We'll learn more about these in an upcoming lab. Then next, if you have a molecular compound, these things are held together by your covalent bonds. The structure of these is simply just a molecule. So if we wanted to represent these on paper, we use Lewis structures to help us model these. And you've actually already seen examples of Lewis structures. You started learning how to draw these in your Discovering Covalent Compounds lesson. But now we're going to learn how to kind of skip the Bohr model part and draw them from scratch. So then our last type of compound, or our last type of structure, is a metallic compound, I guess. So if you have multiple metals that come together, their structure is called an alloy. So this would require multiple different metals to come together and build on top of each other. But if you just have one singular metal, like say you just had a bunch of zinc atoms that were bonding to each other, their structure is called a metallic lattice. So we'll see more of those in our upcoming lab as well. All right, so drawing Lewis structures. Lewis structures are helpful for viewing two-dimensional shapes of your molecular compounds. Really what they show you is how electrons are being shared across your molecule, but they don't actually represent things in 3 dimensions. But before we can do 3 dimensions, we have to do 2 dimensions. So I'm going to give you a couple of practice problems here, walk you through how to draw them, and then you're going to do the 3.5 practice sheet to go through more about how to draw them from scratch. So we're going to start with this compound right here, CnCl. So I've written a shortened version of the steps here for you in your notes packet. If you look at your 3.5 assignment page, it has the instructions for drawing these written out in like way more detail. But since this is your notes packet, I wanted to try and consolidate everything for you. So I'm going to teach you on this page, and then you have the written out instructions on the other page as well, if you wanted to use that to help you follow along. So first step is you want to count up the number of valence electrons for every single atom that you have present. Remember that your valence electrons are the ones that are responsible for bonding, so this is why we have to use the valence electron count to figure out how many we're going to add to our structure, because they're the only ones that can possibly bond. So if we look at carbon on the periodic table, it is in group 4, which means it has 4 valence electrons. Nitrogen's in group 5, so it's got 5 valence electrons, and chlorine's in group 7, so it's got 7 valence electrons. So the total number of electrons available for bonding just means you have to sum these up. So 4 plus 5 is 9, 9 plus 7 is 16. So we have 16 available valence electrons for us to possibly use. That's step 1. Now step 2 is to draw the skeleton. So your rule for drawing the skeleton is whatever element comes first in your chemical formula is the one that goes in the center of your Lewis structure. There are a couple of exceptions. If hydrogen comes first in the compound formula, then you do not use hydrogen. Hydrogen only has 1 electron, but it can only also accept 1 electron, meaning it can only ever single bond, so it's not a good fit for being in the center of a molecule. So here, carbon's not hydrogen, so I can throw it in the middle just like that. Everything else for the skeleton, you now attach to that middle atom just using single bonds. So I would attach just like this. So think back to what these little lines actually represent. This one. Our single bond tells us that these atoms are held together by a sharing of electrons here because these are all covalent. And each little line represents 2 shared electrons. So each line represents 2 shared electrons. The more lines you draw, the more electrons you have shared. These one singular lines, we call them single bonds. If you had a double pair of lines, you would call them a double bond, and a triple pair of lines, you would call a triple bond. That's the maximum amount that it will go up to. All right, so that's step 2, drawing your skeleton. Step 3, you're gonna distribute your electrons to the outer atoms first until every atom has an octet. Or if you have something like hydrogen, hydrogen only needs that one electron, so it follows the duet rule. Basically, you're just trying to use up these electrons until everything is possibly filled. So I started with 16 valence electrons. I already used some of those up in the single bond, so let's figure out how many we used. Between carbon and nitrogen, I have a single bond, so there's 2 electrons there. Between carbon and chlorine, I have 2 electrons, so I'm gonna subtract 4 total electrons from my count, which means that I only have 12 electrons left that I can possibly use. Okay, so I'm gonna start adding electrons around to my outer atoms until they're filled. So chlorine has 2 currently attached to it, so that means I only need 6 more. So I'm gonna draw in 1, 2, 3, 4, 5, 6, perfect. And since I used 6 there, I'm gonna subtract them from my count. Nitrogen still needs some. Nitrogen currently has 2 on it, so it needs 6 more in order to be stable. So I'm gonna draw them around, 1, 2, 3, 4, 5, 6. Subtract that out, and now I have 0 electrons left for sharing. Okay, so now what this means is, since I'm out of electrons, I have to check and see, is everything currently stable? Carbon has 8 electrons. No, chlorine has 8 electrons around it right now. Nitrogen has 8 electrons around it now, so those are both stable. They have their filled octets. Carbon in the middle is not, though. Carbon only has 4 electrons on it, so this thing's not stable. So what you have to do now is you have to make double or triple bonds to try and share more electrons to make things more stable. So now you have to decide, who are you going to share with? So there's a couple rules for this. Your general rule is that you want to make 2 double bonds before you make a triple bond. But there are some exceptions. If you have hydrogen or if you have a halogen involved, they will only ever form single bonds. So what this means is, if I look at my little compound here, I have chlorine and I have nitrogen. Chlorine is a halogen, so chlorine can only ever form a single bond. If you think about why that is, think about the actual bonding structure where this came from. Chlorine started with 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So that means it only has one spot where it can fill, where it can accept another electron from a neighboring atom. And the rule is you can only give as much as you can take. So since chlorine, why do I keep saying carbon? Since chlorine can only give 1 electron, it can only also take 1 electron. So this is why it can only form a single bond. And then hydrogen, like we've talked about earlier, it can also only accept 1 because it wants to fill a duet. So that means I have to share with nitrogen in order to make carbon become stable. Remember that these things share in pairs. So this pair I'm gonna add into a bond with carbon just like that. And that would make carbon now have 6 electrons. So it's still not stable. So that means I need to share another pair of electrons, boom, 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 boom. And now that makes carbon stable. So remember that the way that I'm teaching you to draw Lewis structures right now is like a cheat sheet method, not using the Bohr models, right? So it's kind of like your quick way to drawing these without actually having to think about structure. But keep in mind, this does not mean that nitrogen is sharing 2 electrons with carbon and carbon's not sharing anything back. This is just our quick way of drawing these structures. In reality, because there are 6 electrons that are being shared between carbon and nitrogen right now, that means 3 electrons had to come from carbon and 3 electrons had to come from nitrogen in order to make these things possibly share. So I'm going to take this structure and I'm going to redraw it now for how it would actually be drawn correctly. So chlorine has 3 lone pairs attached to it, 6 unshared electrons, and it's bonded to carbon here in the middle. Carbon is sharing 6 electrons with nitrogen, which indicates a triple bond, and nitrogen still has 1 lone pair of unshared electrons on it. So this is the Lewis structure for CnCl. Okay, now let's talk about our last one, carbon dioxide. So again, go back to your first step. Carbon has 4 valence electrons, and each oxygen has 6 valence electrons. So that means that there are 12 electrons from oxygen and 4 from carbon, so I have 16 valence electrons, again, available for sharing. Second step, draw your skeleton. First element in the formula goes in the center. C goes in the middle. I attach every other element with single bonds. Now I've used up 4 electrons in those bonds, so I've got 12 left to fill. Next step, distribute your electrons to the outer atoms first until they are stable. Now oxygen has 8, and this oxygen now has 8, and I have no electrons left for sharing. Okay, now I check. Oxygen's got 8 on it currently, yay. This oxygen's got 8 on it currently, yay, but carbon only has 4. Ooh. Okay, so that means that I have to share some electrons from oxygen with carbon in the middle. So I'm going to take this set of electrons and I'm going to share it with carbon to make a double bond. Okay? And now if I go back to that rule, it says that I have to make 2 double bonds before making a triple bond. That rule didn't apply to letter A that we did first because we had a halogen present. Here, we don't have any halogens, so I definitely want to make double bonds before making triple. The less you have to share, the better your structure is going to be. So take one from here, and now I'm going to make a double bond on this side, and that now gives carbon 8 shared electrons here in the middle. So if I redraw this structure, each carbon is double bonded to each oxygen. It does not have any lone pairs itself, but each oxygen does have 2 lone pairs. So I'm going to draw them around just like this. So there's my Lewis structure. Okay, so this is kind of your quick little introduction to drawing Lewis structures. You're going to now go and do 3.5, the Lewis structure packet, to get some more practice. If you're looking for more clarification on how to draw these, there is one more mini lecture that can help you that walks you through some of those practice problems. So feel free to check that one out. Bye, everybody.